Hello students, welcome back to Future Foundation. Students, in last class of vectors and 3D, we discussed equation of a plane passing through a point and normal to a given vector. Now in today's class, we will learn how to find the equation of plane passing through three non-collinear points. So let's start the class. Write down the heading, equation of a plane passing through three given non-collinear points, right? Suppose this is a plane for which we have to find the equation, and let's say this is these are points A, B, and C having position vector A vector, B vector, and C vector, right? And let's say P be a general point having position vector R vector, right? Then PA, BA, and CA. These three vectors are coplanar vectors. So box of these three vectors will be 0. Okay, what I am saying, let's say A, B, and C having position vectors A, B, C respectively are three non-collinear points as shown in figure. Let P having position vector R vector be any point in a plane. Then these three vectors are coplanar vectors. So box of PA vector, PA vector, CA vector is 0, right? Because these three vectors are coplanar vectors. Or box of R minus A, B minus A, C minus A is 0. Or R minus A dot B minus A cross C minus A is 0, right? Or this can be written as inside big bracket or square bracket. This if I write down the cross product, or if I distribute these A and B over C and A, then this will become A cross P plus P cross C plus C cross A is equal to 0. Or R dot A cross P plus P cross C plus C cross A is equal to A dot A cross P plus P cross C plus C cross A, right? Or you can say R dot A cross P plus P cross C plus C cross A is equal to A dot A cross B is 0, and A dot C cross A is also 0. So it will become A dot B cross C, and which is box of ABC. Or write A dot B cross C. Okay, and I can also write it as R dot A cross B is box RAB plus R dot B cross C is box RBC plus R dot C cross A is box RCA, which is equal to box of ABC. In RHS it will become box of ABC. Okay, fine. So this is vector equation. Now as we know, this is a normal vector or vector perpendicular to the plane, normal vector. So if this is a note, if P is the length of perpendicular from origin to the plane, then P is equal to box of ABC by mod of A cross P plus P cross C plus C cross A, right? Now we will also find the Cartesian form. Also, now let us take A, B, C having coordinates x1, y1, z1, x2, y2, z2 and x3, y3, z3. So let A, x1, y1, z1 be x2, y2, z2 and C, x3, y3, z3 and P be x, y, z. So again PA vector and CA vector are coplanar vectors. Then determinant of BA vector and CA vector will be 0 because box will be 0. So determinant of x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1 and z3 minus z1 will be 0, right? As simple as that. This is the only theory for this case, right? Now let us take some questions. Find the equation of the plane passing through A 2 2 minus 1, B 3 4 2 and C 7 0 6, and also find a unit vector perpendicular to this plane, right? So here are 3 points, right? So we have to find the equation and using Cartesian form we can get equation in a very simple way, that is determinant of x minus x1, y minus y1, z minus z. So minus minus plus, right hand side it is 0. x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1 and z3 minus z1, right? Determinant of x minus 2, y minus 2, z plus 1, 1, 2, 3, 5 minus 2, 7. X minus 2, 14 plus 6 minus y minus 2, 7 minus 15 plus z plus 1 minus 2 minus 10 equal to 0, right? So it will become 20x minus 40 minus plus 8y minus 16 minus 12z minus 12 equal to 0, okay? Or 20x plus 8y minus 12z minus 68 is equal to 0, or 5x plus 2y minus 3z is equal to 17. So this is the required equation of a plane. Now one thing we also have to find, and that is a unit vector perpendicular to this plane. So we can clearly see the normal vector perpendicular to the plane, which is n vector, is 5i cap plus 2j cap minus 3k cap, right? So unit vector in the direction of n vector will be 5i cap plus 2j cap minus 3k cap upon root over 5 square plus 2 square plus minus 3 square, and which is 5i cap plus 2j cap minus 3k cap on root over 25 plus 4 plus 9, that is root over 38. Okay, this is n cap. Now let us take one more question. Question is, show that the line of intersection of the planes r dot I plus 2j plus 3k is equal to 0 and r dot 3i plus 2j plus k is equal to 0 is equally inclined to I cap and k cap, right? And also find the angle it makes with j cap. Students, see, one thing I have to show you, and that is there are two planes and line of intersection for two planes will be this. This is line of intersection, right? This is line of intersection for these two planes. If say this is n1 vector and this is n2 vector, they are normal to their respective planes, right? So cross product of these two normals will be the vector parallel to this line. Okay, you can imagine this situation now. If I am taking the cross product of n1 and n2, then the new vector will be parallel to this line, which is the intersection of plane 1 and plane 2, right? This is plane 1 and this is plane 2. So now let n1 vector will be I plus 2j plus 3k and n2 vector will be 3i plus 2j plus k. So line of intersection will be parallel to n1 cross n2, right? Okay, so now n1 cross n2 is determinant of ijk 1 2 3 3 2 1, right? So I times 2 minus 6 minus j times 1 minus 9 plus k times 2 minus 6. Okay, so this will be minus 4i cap plus 8j cap minus 4k cap. This is n1 cross n2. Now what we have to show? We have to show that the angle between n1 cross n2 and I cap and the angle between n1 cross n2 and j cap are equal, right? So now let's say theta 1 is the angle between n1 cross n2 and I cap. So theta 1 will be the angle between n1 cross n2 cap I cap, right? And which is equal to minus 4 I cap plus 8 j cap minus 4 k cap dot I cap on mod of minus 4 I cap plus 8 j cap minus 4 k cap dot I cap, sorry, mod I cap. So it will be minus 4 on root over mod of phi is 1 and mod of this, that is root over 4 square, that is 16. I'm directly writing 16 plus 64 plus 16. So sorry, this is nothing but, yeah, so what I'm writing, cos theta, it is cos theta 1 basically. It is cos theta 1, and when you say it is cos theta 1, cos theta 1 is minus 4 upon, I'm not taking mod, you can take mod also. So cos theta 1 is this minus 4 upon root over 96, or minus 1 upon root over 6, right? Now again say theta 2 is the angle between n1 cross n2 and k cap. So cos theta 2 will be n1 cross n2 dot k cap upon mod of n1 cross n2 mod k cap, right? So it is same, which is minus 4 I cap plus 8 j cap minus 4 k cap dot k cap, which is minus 4 upon root over 96. So cos theta 2 is again minus 1 upon root over 6, and here cos theta 1 is minus 1 upon root 6. So therefore cos theta 1 is equal to cos theta 2 implies theta 1 is equal to theta 2. So first part has been proved. Okay. Now let's come to second part. Angle between n1 cross n2 and j cap. Now let phi be the angle between n1 cross n2 and j cap. So cos phi will be minus 4 I cap plus 8 j cap minus 4 k cap dot j cap upon root over 16 plus 64 plus 16 to root over 1, and which is 8 upon root over 96, or 2 upon root 6, or root over 2 by 3. So phi is equal to cos inverse of root over 2 by 3, which is the answer for second part. So students, for this class we are done. Let's meet in next class. Till then, bye bye, take care.